Hello and welcome to another free code session. My name is Jason Bach, and I did close out this issue. So I went through all the tests, updated all of them, and that was a little bit of a slog. That took some time, but it was mostly just fixing the fact that there are no rock create or rock make attributes anymore. It did clean up some things in that now each test, except in one or two exceptional cases, will always make both types, the create and the make. And so I don't have to have separate tests for those. That does feel like it makes the test execution slightly faster. That's objective. Or I'm sorry, that's subjective. It's not objective, it's subjective. But now where I used to have two different tests where they would both spin up a need to run the generator and produce output, I only do that once. Now that creates two outputs, which I would have to do anyway, but I only have to do one execution path to get the generator to run. So that's a little bit more efficient. And it also makes it more consistent to say, if I'm testing this scenario, I want to see what happens with both sides of the equation, so to speak. So that's done, and that's good. So we're going to move on to this one, which is ref-like types. So I mentioned before that with C#13, there is this new anti-constraint idea called, well, that's what it's called, but it now has the ability to say, I allow ref structs. Constraints always say like a type has to be a class or it has to be a struct, and you can't have both. Or a class, or the type parameter has to be a class or a struct, or the type parameter is unmanaged, So it does things like that. That's what constraints do. This is an anti-constraint. It says, I allow this to happen where I didn't before. So in the case of ref structs, where we used to not be able to pass them into type parameters, now if we say allows ref struct, you can do it. Of course, you have to be a little careful because you can't just say that and then use that everywhere you want, because you can't capture a value and store it, because then your thing, well, you could, but then your thing also has to be a ref struct, blah, blah, blah. So it still has all those rules in place. But what this should do is help me get rid of some code. And let me explain what I mean by that. So what I did is I just created a console app that references rocks so it can do code generation. So what I did is said I want to create the code for this type where data is a ref struct. So it created it, and then what I also did is I captured the code by omitting it, and then I took this out, I took this out, and so now I have that code in a folder and I could look at it to see what it does. And as you can see up at the top here, we're doing all this projection stuff. What you're going to see in a moment is that all goes away. That code that I've just pulled pulled up and just showed as this one line of code is actually all of, come on, expand it. There we go. It's all of this. And of course now it's all collapsed. We need to expand it all. But this is what I got to generate every time. And yes, I can use raw string literals and make it a little bit easier, but I have this hash code that I got to create, blah, blah, blah. And then it just trickles down through everything else. So what I did is I said, well, what happens if we take this code and create our ref struct argument? Now I'm going to have a separate ref struct argument. I put in my notes that maybe I could get away with not doing this and everything is one argument, but that's not going to work. So because of the case of an argument of t can capture a value, and in fact, if I go show you argument of t, that one can capture a value, and you can't do that with a ref struct unless you are a ref struct. So that would start to trickle through and change things a lot. So I was like, no, let's not do that. We'll have one type to rule them all. And so this will now allow all ref structs to come through. And it essentially acts exactly like this projected type, this created type, except it's now generalized because of the generic type parameter. So yay, we're good there. We can use a predicate for evaluation, which is nice. We can also use, if I come back to my handwritten code here, you see now all the projection stuff has gone away. For the handler, for the callback, because func and action have also been updated to allow ref structs. So now we don't have to create that callback. We can say it's just a func of data and data, exactly what we're doing already. So that doesn't change at all, which is awesome. The return type still can't be the actual return type because, again, that would be a value that we have to capture and that would get messy. So we still have to say you have to return value a func, and then what happens is that's instead of saying new data, you just do this. And it's already what Rocks does. And then if I want to get that value, you'll notice that the value, if I would run this, would be 3 because that's what it's returning. Yeah. And then I can also do things like here saying, let's evaluate it and say if value is equal to 2. Okay. And that works too. I've already tested that out. So it makes things so much cleaner. It makes things so much more reasonable and readable too, in a way. This is now going to have to be, we're setting up the code in there to say, well, it's got to be a ref struct argument, not just our projected type, but instead of an argument, it's a ref struct argument, and everything else is the same. So this is all the same. The code that we generate here is the same, and that we have to actually make sure that we're doing a call to return value and not just making sure that that is an actual function call and not just returning this. But we already do that, so that doesn't change. Method expectation, this will now be a ref struct as we just did up above before. And then I think down below here in the dormants, these clean up because now we can use these and these. I'm kind of excited about this. Hopefully that this will go through, and doing an example here hopefully should work. I'm going to have to do the thing with params, read-only span, to see what happens there. But I'm hoping this also cleans that up. Let's get to it. I have time to record 1 episode this morning, maybe 2. Depends if I feel ambitious enough. My wife and I are going to see Deadpool and Wolverine, or Deadpool v. Wolverine. I don't know what the title of it is, but it's the 3rd Deadpool movie. And we're seeing that on a Sunday morning. So it's a little cheaper that way to do it. In fact, the best time to see a movie is like on a Tuesday afternoon or something like that, because they're really cheap then. Going to see a movie these days, if you try to see it like on a Saturday or Friday night, it's like an arm and a leg. It's just ridiculous. So in any event, old man babbles. Let's actually do this. So I have a branch made. That's where I've been doing all this stuff. So the first thing we want to do is where we have an argument here, we want to have a ref struct argument. Okay. And we've already built this. So we can just take this, get rid of that. Why did you put a license up there? I want to remove unnecessary headings. Why would you do that? And there we go. Now we have to do some... Why are you complaining about... Target runtime doesn't support ByRef like generics. Yeah. Oh no. Oh no. Okay, I have a workaround in my head. I would say a bad word here and then to bleep it out. But I just realized that, yes, I can't do this because, again, why? We have to target .NET Standard 2.0. This is just driving me nuts as a author of a generator. I know how to work around this. I already have in my head how I'm going to work around this. So it's not like a big deal. But it is extremely annoying because I would just like this to happen. I just completely forgot that in .NET Standard 2.0, it doesn't know what this is. I'm always assuming that when when Rocks 9.0 version gets released, that you are targeting .NET 9. That's going to be a requirement. So, yeah, this sucks. The way to get around this is actually not too bad. Hold on. So this is the solution, okay? Which is you just call this register post initialization output. And that allows you to generate code that will be done once, and then you can actually reference this within your source generator. This isn't too bad. It stinks a little bit, but it's not too bad. We can get around this. So we say in rock generator here, we are generating this through register source output, and this is in initialize. So we can do this, I think, anywhere within here, because when you call these things, this is basically just saying this initialize tells the compiler, hey, I can do these things. And so these get called all the time. So the post one doesn't, though. That one actually gets called only once. What I want to do here is something a little bit more generalized. I don't want to inline the code here. I want to say, let's do this on the because you do it on the context, right? Yes. Yes. We want to have an extension that says, I hate that it does that file, internal static void register types. And we'll say this self. We're going to only do one. So we'll do this, just grab that code for now. And yes, it wants me to do an expression bodied, which is fine. We can do that, as we should. That's our standard in this code base. And this shall be self. Source text, you don't know what that is, but you do now. And what we want to do here is we want to say ref rocks.ref struct argument.g.cs. Okay. And then we're going to do a raw string literal here. And then we'll make sure that we do encoding. So not that bad. Now the one thing I want to use here is a trick. So if I go to my issues in rocks, this, I don't know how official this is. But in this case, this may help out tremendously. Because now I can see what the code looks like. Let's come back here. We're going to grab all this. We're going to get rid of that. And we're going to come back here. And we're going to plop that code in there. And we're done. This playground app has actually turned out to be quite nice, because if I ever have to do something like this in the future, I can play with the code there, get it into the right structure, and then just plop it wherever I want. And I'll know that it's quote unquote correct. So that's nice. I like this. So we do want to do the global.system.predicate. So let's actually, before we go too hog wild here, we want to say global.rocks.argument. Okay. We want to make sure that we are saying global system.serializable attribute. We want to basically make sure, damn it, that we are global system.predicate. Having everything rocks.validation state is uniquely, you know what I mean. And then this can be global system, and we can do that. And actually, we could change this into being this a value, not a pointer, not a pointer. No. This equals that, and then that needs to be that, which is fine. We do that. We want to put this here. Perfect. Okay. Now, before we go any farther, we've got that there. Let's take out in rocks the thing I just put in, because we're not going to have that there. And let's just quickly run our playground app just to make sure that the code we just created didn't break, and it did. The typer namespace. Oh, we need this to be in namespace rocks. That's right. There we go. And now this should all go away. Now we should be able to run it. And we get okay, so that's good. So now let's take this, and now let's go into our not our expectations, our extensions, and plop that into here. Boom. Now we can do it when we go to our generator and we say context.register types. And so if we ever have the need to do this again, we have one call that we have to do. And in this case, what it's going to do is generate this one. If we have to do more, we could put these all into like private methods and do whatever we need. But this is the point at which we can put in our own types. Nice. Let's quickly run our tests here and see what happens. Well, 175 failed. Not what I was hoping for. What happened? Oh. Oh my God. I can get around this. I just can't get around it in the time that it takes to finish this episode. Again, didn't think about this, but these are all generating this file now. So whenever I create any generation, I'm always going to be creating this with this value. Let's be a bit smarter about how we do this. We want to make sure that we can easily in a test say that, yes, I created, if I need to create more of these, I want to have a way to quickly add to, for example, if I come into this here, what's happening is, sure, this is correct, but I need a way to pass in more. And if I'm not careful, this could get to be quite the pain. So what I may need to do in my test now is create a method that says, what are the files that you're going to create in your test along in the code that you're going to generate? And then what about, well, no, this isn't going to work off the top of my head, because I need now a way to capture this text in a way that I can say in the test, this is what it should have done. But take these outputs, because now in a lot of my tests, there's actually two. Combine them with whatever this would do, but not in a way here that information I can find outside here. And then it's also used within here as well. So yeah, I know how to solve this. I know how to do this. I just need to change it. And I think I got time for one more episode. So we're going to start doing that so that we can support this in our tests and make it a little bit easier to handle. And then we can move on with this ref struct argument implementation. Thank you all for watching. Leave comments and questions below. See you in the next episode.